Hello, this is Mr. Huff, and I want to talk about human factors and flight physiology. I want to talk about a couple of things first that are not in this slideshow that would be picked up elsewhere if we were in class, but we're not in class, so here we go. Sometimes we have to look at human behavior. So we have this person, they need to go from point A to point B, and it's really obvious the way to get there: straight lines, shortest distance between 2 points on a plane. But whenever the person actually goes from point A to point B, they don't take a straight line. And if that's all you look at is the path that they take without considering the context, you really don't understand what their motivation was when they did that. So as you start investigating, why did they not just go in a straight line, you learn things. For instance, there's a forest, and there's a building in the way, and there were lions, and there was a train. And that's why they had to take this circuitous route from point A to point B. So the point of this is, without the context, it's very difficult to understand human behavior. Another thing to recognize is, let's just look at the slide, the causes and consequences of operational errors are not linear in magnitude. And if you compare these two events, exactly the same thing has happened, but the consequences are very different. In the first case on the left, you have the person that has dropped the flowers from the window and they have fallen to the ground and the pot is shattered. In the second case, the person has dropped the flowers from the ledge and it has fallen 3 stories to reach the person on the sidewalk and has probably killed someone. So the same error occurred, but the consequences were very, very different. Another thing to keep in mind when accidents happen, there are statistically, when they've looked at all of these aircraft accidents, millions of operational errors are made before a major safety breakdown occurs. Millions. Like, there are a lot of events. So really the idea is there are a chain of events that occur. It's not just we were flying along and then this broke and we crashed. There's always a series of little things that happen leading up to that. So it's like just one thing that causes something else to happen that causes something else to happen. For instance, you have something where the flaps on the aircraft aren't working, and you have a checklist where the pilot just looked at them and didn't actually try them, so they kind of skipped something. We have a deviation from the checklist, and then there is a warning in the aircraft saying there's something wrong with this, and then all of those happened before the accident actually happened. So there's always some chain of events leading up to an accident where people make mistakes, where things don't work, where things are giving you warning indications that are not heeded. So the chain of events is important to understand an accident. And then the last thing I want to talk about that's outside of this PowerPoint is the dilemma that management decisions have to deal with. So you have resources. So as in a business, you only have so many resources that you can apply, and you can apply resources to protection and building a safe product, and you can apply resources to production. If you put more resources into your production and less into protection, you end up with a aircraft crash. And if you put more money into protection than you do in production, you have a very safe airplane, but you can't sell it because it's extremely expensive, and you can't make it because you don't have any production capacity. So management is always trying to balance these two concerns, protection and production, and how do you apply your resources. All right, let's get into some of this content now. So what this slide is saying is that we've had advances in technology that have reduced the requirement for human input, but at some point there is an input required from people, and there is some sort of decision that has to be made at some level. What this is speaking about is, as a designer of an aircraft, if you're building an aircraft that is not going to have people in it, your job is greatly reduced as far as the complexity of your design. However, you have to design for living organisms to inhabit your device, and that calls for a lot of additional design constraints. And you have to consider, what is a person capable of? And this is where we get into the idea of flight physiology. So basically what this is saying is, when you put people into an aircraft, that introduces limitations on what the aircraft is capable of, and it also introduces a dynamic you have to accommodate for. Accommodate. What this is saying is that most accidents and incidents are things that go wrong. Accidents are when things really go wrong. Okay. And usually an accident is a series of incidents, and most of the contributing factors to incidents and accidents are human. So this is the SHEL model. This is something that the ICAO has come up with, understanding how incidents and accidents happen, and you have software, hardware, environment, and liveware involved. Okay. These are all places where you can have a contributing factor. So liveware simply means the pilot. So if the pilot has an issue, all of the reason it's central in the SHEL model is that if the pilot has an issue, everything else is affected. So let's talk about some liveware failures. You have incapacitation, and they give you this list of little stuff. So you could have sudden, and that's where the pilot collapses or suddenly dies. You have subtle, this is something that's happening, but it's unnoticed by the crew. You have total, which is completely incapacitated and nobody can do anything. Partial, this is a pilot that's fatigued or sick, not feeling well. Distractions, you have personal issues. You just got in a big fight and you don't feel like flying. Okay. Control issues, you're mad because you had a bad commute to work still, and you're distracted by that. And then you have the recognized and unrecognized. And this is where the pilot may or may not be recognizing an issue. So one of the things is a human body is made up of multiple systems, and those systems have to be understood for you to design an aircraft for people to operate in. So let's quickly just look at these body systems. They are not going to be completely described in this. So here we go. You have the cardiovascular system. That includes your heart, blood vessels, arteries, that sort of thing. You have your central nervous system, your brain, your spinal cord, and your nerves. You have your musculoskeletal system, so you have the bones and the muscles and the tendons and the ligaments that help you move about. The respiratory system, which allows you to take in oxygen and get rid of carbon dioxide, so all of your important body functions can proceed. You have the metabolic system, which coordinates all of your body systems together. And here's a few of those items. The vestibular system, which is important for balance and your sense of spatial orientation. If you're a pilot and you do not have a good sense of balance or a sense of spatial orientation, you're going to be making decisions based on confused messages. So that is a very quick just list of the body systems that are important. And I'm going to leave it up to you to research those a little more.